Hello, everybody here? Let's begin. So, my name is Roger. I work here at 1337. And today I'm going to talk a bit about integration testing with using Docker as a tool for this. Hello, Artyom. Welcome. And to do this, I have prepared a small application. We're going to build this, or I've built this in forehand, except the alien, of course. That's just the user of this system. So we're going to have 3 services. We're going to have a targeting service that's going to look up some coordinates for different cities, and they're going to be stored in S3 in the cloud. And then we're going to have a spaceship service that's going to integrate with our spaceship and launch the ships. The ships are going to be stored in a database. In this case, it's going to be a Redis database. And then we have some kind of aggregation service that will call the other services, so we can have something to integrate. And the evil alien will, of course, use this service. Okay? So the different services are here in the different folders. You cannot probably not read this text, but you can start looking at the targeting service. We're using Node for all these services because that's the language I'm using the most right now. So it's just going to be a simple express service, all of those, that will listen to different routes. So this one is going to answer to this target route, and it's going to look up something in S3 here. We're just using the normal AWS client here for JavaScript, and look up in our bucket here a CSV file with the target that has the name. And that's about it. It's a very, very simple service here. And the health check is just to see if it's up and running. Our spaceship service looks about the same here, but we have a launch endpoint which we can post a ship code and a destination, so we know which ship we're going to launch and where to launch it. So what this does, it will use a ship repository, which in turn will use a Redis client to look up the ship in the database. And we can also set the status of the ship. The ship looks like code and status. That's it. And we also, after we have get the ship, we're going to validate it to see if we have a ship and if it's ready for launch. And then we're going to interface with our hardware devices here. So, of course, I don't have any ship, so I'm just pretending I'm doing something here that takes a bit of time, just to make it harder to test this. So what it does is just going to print out, it's going to move the ship and start the engine and stuff. So that's the spaceship service. The colonization service will have an endpoint to colonize. You're going to send in an array of targets. That's an array of cities you want to colonize. And this one is going to use the targeting service and the spaceship service. Just like this, it's going to get the target. So it's just going to make an HTTP request and get the response. And here, it's going to post the ship code and the destination it gets from the targeting service. So that's the application. So to run this, we also need some data here. So I just made a simple, of course I had to use leftpad because you cannot write a Node.js application without using leftpad. It's impossible. So what it does, it just generates a few ships and inserts them into the database. So to start all this, we need some things here. First, we're going to need a Redis server. So we start that. then we can yes, left pad exists. We're going to insert some data there. I'm going to install the others. npm. Num. Like that. So this port listens to port 1339. This one is 1338. Can you guess the port for this one?
1335.
Yeah.
1340.
So we have started this application. Kind of cumbersome to do all this, but that's how you have to do it when you don't run Docker. And we can try this out. I'm going to send some JSON to this one. To the colonization service, was on 1339. To the colonize endpoint. And we're going to send the targets as an array. And we have Stockholm. Oh yeah, I could also, before I do this, show you this. This is the bucket we're going to use in S3. So we have the targets here stored as files in S3. So we have Stockholm, we have Lund, and we have Korpilombolo. It's actually a city in Sweden, if you didn't know that. So if we run this, it's going to do stuff here. The hardware engine is going to run, starting engines. It's going to wait. It's going to move ships. It's going to return stuff. We have to wait, and there we go. So we ran all the services. We had a path through the whole application there. Okay. So how are we going to test this? Right. We could exit all those because we don't need this anymore. There you go. Clean up. So if we're going to take a look in the in the spaceship service, we start with this. Okay. So what have we done here? We're going to put this service in a container. So we're going to start it up in Docker instead. So we need a certain amount of things here. Let's start with this. Oops. So I'm going to change the port that we're going to listen to 80, because I want all my containers to listen to port 80 instead. That's one thing. And we can also take a look in the folder here. So we have a Docker file. This was going to describe our container. So we're going to start with an Alpine-based node image, which is a very small Linux distribution. So we get a smaller footprint for the whole. Instead of like 600 megs, we get like 50 megs with the whole nodes implementation. Then we're just going to copy our dependencies file, install it, copy the application, and expose port 80 and start it. That's what we're going to do in the container. To make things easier here, I have created a make file to build this container, so I don't have to type all this every time. So I could just type make build local, so we're going to build this container. All right? So let's try this. So first, we're pulling the base image, just like not too much. Then we're doing all the stuff that we described in our Docker file. Installing dependencies. Of course, hiccup. No, there we go. So, So we have our image built. So we can look in here. So we have the base image, and we have our spaceship image. Okay? So we can try and start this one. We remove it after we're done with it. Oops. And I tagged it local. Oh, we don't have a Redis server. So we're going to spin up a Redis server as well. And also it looks for the Redis server on this local host, but we want to be able to change this easily. So in the code, in our Redis client, we just look up an environment variable for the host, so we can just change it very easily. And to set environment variables here, we can just do like this. Or something. And when we now run it, it's going to look for the space Redis host. Simple. I'm sorry. I think I'm getting a cold or something. So we're going to start a Redis server, and we're going to do it in Docker. So we're going to create like a network in Docker. We can create networks there. Let's call it SpaceNet. All right. So we're going to run in the background in this network. SpaceNet. We're going to call it Space Redis. And we're going to use an image that I created before. That's called Alpine Redis. And that one is just Redis running in Alpine. We don't have it locally, so it needs to pull the image. There we go. So now we have a Redis server running in Docker. So now if we run this one instead, oh, sorry, I need to specify the same network. Butterfingers. SpaceNet, I believe. Now we connect to the Redis server. Okay? So that's how we can run stuff. This is dclean is a command, just a simple shell script I created too. Because when you work with Docker, you get a lot of extra containers just laying around and extra images. When you build new images, you get layers of other images that's lying around and doing nothing. So I just created a small script. It looks like this. Just going to stop containers, deleting all the containers, removing all networks, removing unneeded images, and so. So that makes my life very much easier when I work with Docker to have this clean script. Oops. There you go. So, now when we have this service in a container, we also want to be able to run tests in the Docker environment. So, if we take a look at what we have here, I've added some unit tests for the spaceship service. And when I run unit tests, I don't want to go to the real database or to the hardware interface or anything like that, so I'm just going to mock those away and then run some tests to verify that my logic works. And how do we run those tests? We can take a look in the package.json. We have a script here. So we can run test unit. So this is just to start the tests. And in the Docker file, I have now added a build argument. So when I build the image, I could specify arguments, which in this case will set an environment variable in the build when I'm building this image. So this node env is for node. When you set it to something else than production, like test, it's going to install the dev dependencies that we're going to need. And when we set it to production, it's only going to install the production dependencies. So now we have those dev dependencies we need for the testing. So we can build a container we can use to run the unit tests in. But that's going to be another image that we're not going to send to production. All right? So therefore, in my make file, I have added this build test, which will put this build argument to set the node environment to test, and we're going to build the image and label it test. And I also have this test unit will run this image in a container, and it's going to run this script. And hopefully that's going to work. So I'm just going to be able to write make test to run my tests in Docker, like this. So we're building the test image. Wonder why that is so slow. There you go. And the output looks like this. So we have run our unit test in our container. So we have the local image, which is the production code. And we have the test image, which we use to run our unit tests. Okay? So let's add some integration tests. In this case, our integration tests, they will first wait for the spaceship service to come alive. And so I created this small test tool called wait for service. And you can just send in a service name or several services, and what it will do, it will retry this health check route. So it's kind of a convention to have a health check route to see when it responds. So it's going to retry it until it responds or until it times out. So we know our service is up and running. And when we do that, because we run our tests in the same network, in the same environment in Docker, we could just request this service like this. All right? So we have some test data. So we're actually going to test against the actual Redis database, which we're also going to spin up in Docker. So we're going to insert some test data before each test, and we're going to clear the test data after each test. And I also have this test data tool here to just, it's a simple client to insert some data in the database and to clear it. So no magic there. So our tests look like this. We just post this, and we just verify the responses. So the tests are very clean. It's kind of easy to understand what they're doing. And this is my view of an integration test, where you test the service from outside and just, but do it against everything that we should do. We have a small problem here, because we cannot control this hardware whatever we're going to call it, hardware interface, this one. So when I'm doing integration tests, I really don't want to send away the chips. So I have to code my way around this. So I'm going to do this. It's a technique I'm using a lot to just bypass code I don't want to use in the integration test. And this is going to be there in production as well. Because so I kind of have to be smart when I code these interfaces or these things that I don't want to be having in my tests. So what it will do is just check for this environment variable, see if it's there. It's just going to resolve it straight away instead of just doing all this, sending away the ship and so. Okay. So we can look at this file. We're going to use Docker Compose to spin up this test environment instead of doing all this manual Docker run and everything. So we can just create this file. This describes our integration test environment. So we say we're going to have the spaceship service. It's going to use this image. It will have these environment variables. So we're going to tell it where the ready server is, and we're going to say it's an integration test we're running. So it can bypass that hardware. And we're also going to tell it that it's going to depend on this service, so it will spin up this one first. And that's all you need for starting up an environment with Docker. You just need this file. And what Docker Compose will do, it will automatically create a network for you, which you can specify the name for. And it will pull down the images if you don't have them. And it will just start everything for you. Okay? So in the make file, I have created a new task here that I call integration test environment. It depends on build local because we need the local image. And then I'm going to do Docker Compose. And this -p will name the project, or project, it's called project in this. But this will actually be the name of the network. So the network name will be this. So the project name, which will be colonize in this case, _default. That's what Compose will create for you and run the services in that network. Because we need to know that network because we are going to run our integration tests in our test container against our integration test environment. So we need to do it in the same network to be able to access the services. So to run the actual integration tests, we're going to build the test container. We're going to set up the integration test environment. Then we're going to run in the same way as we did with unit tests, but to specify the network and the test labeled image, and we're going to run the test integration script. And when that one is done, we're going to just run Compose again to bring down the environment to clean up afterwards, no matter if it fails or if it succeeds. So to set up the integration test environment, I just do make integration test environment. And of course I have to install everything again because I've added a few dev dependencies. So we have the environment up and running. So we can take a look at it. We have two services. We have the spaceship service and we have the ready service. So, and the networks, we have this created by Compose for us. Okay? And to actually run the tests, we just do make test, which is going to run the unit tests first. Yeah, it's so exciting. It's going to work. Is the network slow here? There you go. Okay, unit tests, integration tests. So we have actually done HTTP requests to our services, down to the database and everything, just bypassing with this cheat technique. And if we do it again, it's probably going to go a bit faster because it's using cached images. So we don't have to wait for the install every time.
Just a quick question. In step 5,
Mm-hmm.
it says that you have node environment to production. If you scroll back, should it be that, or?
Can you repeat the question?
In this one,
Yeah.
the question was in step 5, it says I had node environment production. Yes, that's because we're building the actual production version of our service. Because we are going to test against the real thing. We're not going to test against the test environment code. So we need the local production version to run. With that difference that we have this integration test variable set to true. Okay? So, if we fail a test, so we've done something wrong, the test fails. You can now see that we only get the log output from the actual test container, from that container that we run the tests in. And we're not getting the logs from the servers or the services. So that's something we also need to fix ourselves. So how to do that? Just a small hack in the make file, which if the integration test fails, we're just going to do this line. So Docker Compose can actually list all the services it's running, and we just pipe it to the script like this. So for each container it has, it's just going to print out the logs for it with some new lines to make some space between them. So with this, the output's going to look like this. There we go. We get the Redis server log output, and beneath that we get the spaceship output. So we can actually go in and see what's wrong with the code. All right? And we're only going to show these logs when we fail our test, so we don't need to see them all the time. So if it's green, we're fine. So let's move to targeting. If we take a look here, we have integration tests set up in the same way. But now this service is actually going to access a cloud service, which we don't want to do in our tests either. But we still want to kind of test that mechanism as well. And what we have done here is that we have created Docker container that kind of emulates or simulates the S3 API. And it's actually built from something called Scality S3. It's an open source Node.js based S3 server, which I've forked and modified for my needs, so I can run it in Alpine and such. So that's the strategy when you're working with cloud services in your integration tests. You want to have as many of them as possible in your local environment and still run the actual client code for those services. So we have, at our client right now, we have containers for DynamoDB, we have it for Memcached, we have it for Elasticcache, stuff like that. So the strategy there is to kind of bring it to your local environment. So that's why we're actually waiting for that as well. And then we just do this normal request as usual. And to set this local S3 service up, is going to use this folder, the S3 buckets folder. Or maybe you cannot see this. Where every folder in this is going to become a bucket in S3. And then you have the files and subfolders and everything. So it's going to bring up this and just serve those files in memory, so it goes fast. And how do we know in our code that we're going to use this local instead of going out to S3? Almost the same technique as the...
Is there an environment variable?
There is an environment variable. Exactly. Here we go. So before we just had new AWS S3. But instead, if we have this local S3 variable set to true, we're going to new up the S3 client with those options instead. It's still going to be the actual S3 client, but it's going to run against this. Oh no, sorry, it's not set to true, it's set to the actual host. And these are hard-coded in this. Otherwise, it's just the same code. So when we run this, we also have some unit tests and stuff in there, in the same manner as the spaceship. So much fun. Come on. When I run this at home, it takes like 5 seconds. I have to fix this network.
Internal network or the guest network?
I don't know. It is... No, it's the internal. Should work, right?
You make it better for guests.
Oh. Better for guests.
And how old did you say that thing was?
Which?
The laptop?
Oh, my laptop is 4 years old.
So, Stone Age.
Yeah, it's not the laptop. Trust me.
It burns your lap.
Yeah. So we have some unit tests here. And I'm going to take even longer because... come on. Oh, sorry. The question before, I realized this now. This is always going to say production, because this is what's actual the default value in the Docker file. So we never see the actual value there because that's stored in that variable, in the environment variable when you actually run this. So you're never going to see this tests. Yeah. Well, this was boring. Yay. Nice. Okay. So we're pulling this local S3. Also Alpine based. So it's kind of small. Setting up the environment, run the integration tests. There you go. And we also have this. I'm just going to do this before. So we have in colonization even more tests. We're just going to do the same thing, except we also need to set our test data here because we have dependencies against services that use databases. We also need to set up test data because it's kind of a full environment there. And we also need the files in the S3 bucket because that other targeting service needs that. Otherwise, it's the same as the other one. Just simple requests, and that's it. That's actually all you need. To make things easier here with the dependencies, first we have the environment here. That will spin up all the services. The colonization, we have the spaceship, we have the targeting, the Redis, and the S3. The difference here is that we want to be able to use our production version, our production images of our other services, like the spaceship and targeting. So we haven't specified the images in this file. We have done it here instead, in another file, which only describes which images we're going to use for those services. And we have done this because we don't want to pull all the images from this test environment. If we do that, we're going to try and pull this image from the Docker registry, and that's not going to exist there. It's our local image. So we're going to pull everything in this file instead. And that's what we do here. So this is the dependencies file. So we're going to pull all the dependencies like that. So when we set up the test environment, we're going to build our local, and then we're going to pull the dependencies. And we're going to spin up two files. So we have the first file, and we have the second file. So we can actually specify two different files. And what will happen is they're going to merge and become one file. So whatever is in this file is going to override anything that's in this file or be merged together with that one. All right?
Quick question here.
Mm-hmm.
What happens if you have the same thing in both but different data, so to speak?
What happens if you have the same thing in both files but with different data?
Like
So
some entry in the file that's...
yeah, let's say we have in this one we have environment variables.
Yeah.
And we also have environment variables in this file. It's going to use the last file and override.
The last.
Yeah. Yep. So that's strange though. So we need those production files. So let's do this. So I need to build this one, and I'm going to push it to the Docker registry so we can actually pull it. I'm going to do the same thing with targeting. There you go. So if we now take a look in this, you can see that we have different versions of our services. So we have our local and we have our latest, which now are the same. But the latest should always be like the production version of the service. Okay? So when we run this, everything works fine. If we set this one up, and take a look at it. Oh, that's wrong. Oh, I'm in targeting. I'm sorry. I didn't say anything. This is the one we want. I thought it went too fast. Something is strange. There you go. Yeah, so now we're pulling the actual images from the registry here and using those in our environment. So we have this environment now. We have the colonization with the local, and we have the latest versions of the targeting and spaceship and those dependent database stuff. This is nice to have, but we also want to be able to switch to the local versions of our services, because if we change something in one of the services, for instance in the targeting service, we're going to be able to test our colonization service with that version, with the local version of the targeting service as well. So we need some kind of way to tell this which one to use. Yeah, done. So how to do that? We can take a look in our make file. I'm going to introduce another file, of course, which I call a local. And this one is going to describe which services are going to use the local version. So when we set up the test environment, we're going to build the local, we're going to pull the dependencies, and then we're going to generate this local services file because it doesn't exist yet. So that file is going to be dynamic depending on an environment variable, of course, because we like that. So we have a small script that's going to generate this file for us. It looks like this. very, very simple script. It's going to output every service you specify in this one, separated by semicolon, and just create this for us. So we're just going to use the local tag for those services. And then when we start this, we're going to use 3 different files. The environment, the dependencies, and then this overriding local files. So we always need something in this file, even if we're not going to use the local files. Otherwise, this is not going to work. So by default, we're going to just put ourselves as local, because that's logical. If we do like this, for instance, spaceship and targeting, make like that, the file is going to look like this. So in this way, we can just, when we run the test, specify which services we're going to use as local and which one we're going to use as the production. All right? So we just use the same here. Let's say we just use this, oops. Wrong key. And do like this. We can now see that we're using the local spaceship and the latest targeting. And this is sweet, because we have done some coding that actually will break this colonization service. So we have changed what this service returns in some way. So everything is fine with this. Targeting says, yeah, I'm good. Unit test good. Integration test good. Yeah, whatever. As I said, too much crap. Docker just leaves too much. So targeting, we think it's fine until we run this. So we run the tests for colonization now. And they're also fine. But we know we have changed the targeting service. So we're going to run the test now. And bam, we crash. So something is not right. So that's how we can check if code breaks when we change other services. All right? Oh, sorry. So we're going to fix colonization, right? And we're going to run the integration tests against the local targeting again. Yeah, it works. But to be able to deploy this, we also needed to work with the production version of targeting. Otherwise, we're going to break stuff in production when we deploy this one. Because we cannot deploy targeting before we have deployed this one, right? So we have to try it one more time against the production. No, of course it didn't work, so we have to fix it again. So now we have a version of containerization which works with the production version. Green, nice. And using the local targeting version. Perfect. So I'm happy with this code because I know it's going to work with the old version and the new version. So we can deploy it. So here we go. We deployed our new service, and the fix, kind of easy, but just to show the concept. We can also clean up a bit here, because when we actually run the test so many times, we want a bit less of output, so we don't have to see this build step all the time. So I just added a bit of code to build the image a bit more silent. And I also added this, a make file in the root of all this, which will just traverse down the different folders here and run all the tests or do whatever you want to do by convention here. So you can run all the tests for all the services in one sweep. Like this. So it runs the containerization. And so on. And it does the same thing for each service. So this is kind of powerful when you're developing small services that connects to each other when you want to test them. And of course, you have to set up all this in your CI environment, or whatever you're using so you don't have to do all this manually. So then you could set up the dependencies and try different scenarios very easily. Yeah, that was what I had to show. Any questions?
Just a quick one. What's the reason for Docker to use intermediate containers?
Caching to speed up stuff. Otherwise, you have to wait for the npm install each time. Otherwise, you could cache the result of the npm install in one layer. The question was, what's the reason for Docker to use intermediate layers, containers? It's just for caching. But that's why I like this. Yeah. Any other questions?
What continuous integration system are you using to run this?
What continuous integration system we're using to run this? Whatever you want. I mean, it's just make.
Yeah.
So
So Which one have you had success using?
Jenkins. We're using Jenkins. It works fine. Yeah. All right. Well, thanks. Thanks.